grade 9 students. I am Ma'am Rachel and welcome to our Science 9 class. Today, we will be discussing all about the development of atomic models. Are you ready? Let's start! Have you heard of the word atom? What are the things that comes to your mind every time you hear this word? That's right. We usually hear this word in chemistry and it is the basic unit of matter. There are actually different models of the atom. And that's what we're going to learn today. The different atomic models, who are the proponents, and what are the important informations we got from each models.
The development of atomic models. In this lesson, we will discuss the people behind the development of atomic models. Let's start with Democritus. Democritus on 500 BC proposed that matter was composed of tiny indivisible particles. Though this proposal is not based on experimental data, he is the first person to coin or use the word atomos or atoms, which means uncuttable or indestructible. Next to our list is John Dalton. John Dalton contributed in the development of an atom on 1807. He is a British schoolteacher and he based his theory on others' experimental data. According to John Dalton, an atom is like a billiard ball. That's why we call his model the billiard ball model. And it says that atom is a uniform and a solid sphere. Together with this model is John Dalton's postulates about an atom. There are 4 postulates about an atom according to Dalton. Number 1, elements are composed of small indivisible particles called atoms. Number 2, atoms of the same elements are identical, while atoms of different elements are different. Number 3, atoms of different elements combine together in simple proportions to create a compound. And lastly, in a chemical reaction, atoms are rearranged but not changed. After Dalton was John Joseph Thomson or J.J. Thomson on 1903. His contribution to the development of an atom is based on his experiment called the cathode ray tube experiment, which used beam of negative particles. He discovered the electrons, which are the negative particles within an atom. His model is called the plum pudding model, which tried to illustrate how electrons are scattered in an atom, just like this. In this plum pudding model, it shows us that an atom has a positive sphere, the green one, which serves as the pudding, with the negative electrons, which serves as the plums, the smaller spheres, with the negative charge dispersed throughout. So this is how Thomson described an atom. After J.J. Thomson, we have Ernest Rutherford on 1911. His contribution to the development of atomic model is based on his experiment called the gold foil experiment. He discovered the nucleus, which is a dense, positive charge in the center of an atom. We call this model the nuclear model, just like this. Comparing to J.J. Thomson's plum pudding model, we can see here that the nuclear model shows us that an atom has a center called the nucleus. The nuclear model tells us that an atom has a dense, positive nucleus surrounded by negative electrons. Moving forward, we have Niels Bohr on 1913. Niels Bohr has 3 contributions in the field of chemistry. First, the bright line spectrum, which tried to explain the presence of specific colors in hydrogen spectrum. Second is the energy levels, which tells us that electrons can only exist in a specific energy state. And lastly, he is the proponent of the planetary model of an atom. This is his contribution, the bright line spectrum of hydrogen, and this is the planetary model by Niels Bohr. It tells us that electrons move in a circular orbits within a specific energy level, just like how the planets are moving around the sun. That's why we call it the planetary model inspired by the solar system. Down to the latest atomic model is by Erwin Schrödinger on 1926. He proposed the quantum mechanics, which tells us that electrons can only exist in specified energy states. He worked with the previous study of Niels Bohr. His model is called the electron cloud model, wherein an atom has an orbital. An orbital is a region around the nucleus where electrons are likely to be found. This is Schrödinger's illustration of an atom, where there is an electron cloud. Electron cloud, or an orbital, represents the probability of finding an electron, but not the actual electrons. Electrons are continuously moving, and according to Heisenberg uncertainty principle, it is impossible for us to find the location of an atom at a certain period of time. Let's include another important person who contributed to the structure of an atom by the name of James Chadwick on 1932. He discovered neutrons, which are neutral particles in the nucleus of an atom. He discovered this through the Joliot-Curie experiment and based his theory on their experimental evidence. After the discovery of James Chadwick, we have completed the subatomic particles inside an atom, or the neutron model, wherein proton, neutron, and electrons give an overall charge of 0 to an atom, making it a neutral particle.
From the video that we have watched, we have learned how the atomic models evolved. It all started with Democritus. He used the word atomos, which means uncuttable, to describe the smallest unit of matter. It was then followed by John Dalton, who proposed the atomic theory. Following the atomic theory, J.J. Thomson described an atom using his model called the plum pudding model or the raisin bread model. Following J.J. Thomson was Ernest Rutherford. He discovered the presence of nucleus inside an atom through the gold foil experiment. Like this. We can see in this model that there's already the presence of the nucleus at the center and the electrons surrounding the nucleus inside an atom. Someone also discovered the positively charged subatomic particle called proton, and that is Eugene Goldstein. Combining all these models, we are now using the quantum mechanical model proposed by Erwin Schrödinger. And that is how atomic models evolved through the years. It just started with a sphere, and now we have the quantum mechanical model, which help us to understand elements.